So today, we're going to dive into one of the most ambitious infrastructure projects happening anywhere on the planet. It's a plan that's connecting the future of energy, technology, and science. And the blueprint for this? Well, we found it hidden in plain sight, right inside India's official national budget. Let's see what it has to say.
It kind of sounds like a riddle, doesn't it? Okay, so picture this. You've got this immense amount of power being generated in one place. Think huge solar farms shimmering in a hot desert, or wind turbines spinning just off the coast. But all the demand for that power, well, it's hundreds, sometimes even thousands of kilometers away in these bustling cities and huge industrial hubs. So how do you possibly bridge that gap?
Well, the answer isn't tucked away in some flashy tech brochure or a sci-fi novel. It's right there, in the dense, detailed pages of the national budget. The official documents that spell out a country's real priorities in cold, hard numbers. And that's exactly where we're going today. Now, forget about asphalt and cars. We are talking about a superhighway for electrons. It's a massive, high-capacity network designed for one specific purpose: to move clean, renewable energy from where it's made to where it's needed most. And here's the official name for it: the Green Energy Corridor. You have to understand, this is the critical missing piece in the whole renewable energy puzzle. You can build all the solar and wind farms you want, but without these transmission lines, these corridors, that power is basically stranded. This project is like the circulatory system for India's entire green economy. And here's the proof of just how important it is, pulled straight from the budget. We're talking nearly 600 crore rupees set aside just for the 2026-27 fiscal year. This tells you it's not just some idea on a whiteboard, it's a massive national priority, and it's backed by some serious public money. This slide really just lays out the fundamental challenge in the simplest way. On one side, you have the perfect spots for generating renewables, like sunny deserts and windy coastlines. And on the other, you've got the cities and factories that are hungry for all that power. The Green Energy Corridor is the essential piece that solves this geographical puzzle. And the pressure to build that bridge is just immense. I mean, look at the money pouring into just generating the power. A staggering 10,000 crore for rooftop solar alone, then another 700 crore for big solar grids and 300 crore for wind. All of this creates this huge supply of green energy that desperately needs a way to get to market. So this brings us to the next really fascinating layer of the story. Building the superhighway itself is one thing, but how do you manage all the traffic? See, unlike a regular power plant you can just turn on and off, renewable energy goes up and down with the sun and the wind. To manage this incredibly complex, continent-sized flow of energy, you need more than just cables. You need a brain. And here's the budget for that brain. You can see 600 crore allocated to the India AI mission. That's to predict energy flows and balance the grid, in real time. Then there's almost 400 crore for cybersecurity to protect this vital national asset. And finally, funding for the National Supercomputing Mission to power all the complex modeling. This is where you see it all really come together: the energy, the IT, and the science. Okay, so with an investment this huge, how do we actually measure success? Well, the government itself gives us a framework for it right there in the budget documents. It's a pretty simple but really powerful idea with 3 steps: outlay, output, and outcome. Let's apply that to the Green Energy Corridor. All right, first up, the outlay. We've seen this number before. It's the nearly 600 crore rupees put on the table from the budget. Think of this as the financial fuel for the entire project. So what does that money actually buy? Well, that brings us to the output. That money gets turned into something real, something tangible: 12,760 circuit kilometers of new transmission lines. This is the physical superhighway that's being built. And finally, we get to the most important part of all, the outcome. This is the why. All this money, all this construction, it all leads to one massive goal: integrating a whopping 32,000 megawatts of renewable energy into the national grid. That is the real payoff, turning an investment into clean power for millions of people. So when you take a step back and look at all the different pieces, the huge investment in solar and wind, the advanced AI and cybersecurity needed to run it, and the just sheer scale of the transmission lines, you really get the whole picture. The Green Energy Corridor truly is the keystone. It's the central piece that locks everything else together, making the entire dream of a green energy future possible. And this is where we'll leave it. A project on this scale doesn't just solve today's problems, it creates a platform for tomorrow's solutions.
As this green energy superhighway comes online, delivering tons of clean power all across the country, it just raises this fascinating question. What new industries, what new technologies, what incredible new innovations will it power next?